All right, college algebra class, we're going to go over the final portion of lesson 3. And so we are going to be using our knowledge of lowest common multiples to solve these rational linear equations. And note that what we have now learned about conjugates, if you multiply x plus 1 times x minus 1, we'll get x squared minus 1. So we know that the lowest common multiple is x plus 1 times x minus 1, which is the same thing as x squared minus 1. So we're going to multiply across by the lowest common multiple. So on the left-hand side, we're going to write x plus 1 times x minus 1, and then multiply through 1 over x plus 1 plus 3 over x minus 1. And this equals x squared minus 1 times 10 divided by x squared minus 1. Note that even though this expression and this expression are different, they look different, they are in fact not different. They are in fact the same, right? Because you see how they're equal to each other. One thing I did forget to do here is I forgot to write that x cannot be positive or negative 1. And why can it not be positive or negative 1? If I put positive or negative 1 in any of in these terms, I will be dividing by 0. So those are the two forbidden numbers. So let's work what we got now. So we distribute this across. And so when we multiply this guy times the first one, note that x plus 1 divided by x plus 1 is 1. So all that's left is x minus 1. And that's, of course, being just multiplied by 1. And then we've got x minus 1 divided by itself, so that just goes away, leaving x plus 1. And then that is being multiplied by 3. Come over to the right-hand side of the equation. X squared minus 1 divided by itself is 1, leaving 10. So we have a much simpler looking equation now. So we begin working this through. X minus 1 plus 3x plus 3, right? Because 1 times 3 is 3, and that all equals 10. This is turning into a much easier problem to work. So we're going to combine x and 3x to get 4x. Combine negative 1 and 3 to get 2. Right-hand side is still 10. Subtract 2 from both sides, and we have 8 divided by 4, and we will have an answer of 2. And I can box that because 2 is an allowed answer, right? It does not match our forbidden numbers of positive or negative 1. So 2 is perfectly fine. Okay, so moving on to the next problem. We have 2 over x plus 3 minus 1 over x minus 2 equals 2 over x squared plus x minus 6. So note that if I multiply x plus 3 and x minus 2 together, right, 3 times negative 2, negative 6. 3 plus negative 2 is positive 1. So if I multiply these two guys together, I'll get this full expression here. So the lowest common multiple will be x plus 3 times x minus 2, which is the same as x squared plus x minus 6. And also note our two forbidden values are x cannot be negative 3 or positive 2. right? It cannot be either of those two numbers. All right, so moving forward, we're going to multiply the LCM, the lowest common multiple, both sides of the equation. And on the left side, I'm going to use this expression. On the right-hand side, I'm going to use this expression. So we have x plus 3 times x minus 2. And then we write the left-hand expression. And this all equals, right? That's what we're multiplying the right-hand side by. Now I write the right-hand expression. All right, so on the left-hand side, we distribute these two to both terms. X plus 3 divided by itself is 1, so the first term, we only have an x minus 2 there, and that's being multiplied by 2. On the next term, x minus 2 divided by itself is 1, so the x minus 2's go away. And all that's left is the x plus 3. And that's being multiplied by that 1 right there. You don't have to write the 1, but we're going to. Now we move to the right-hand side. X squared plus x minus 6 divided by itself, of course, is 1, leaving us with just this 2 right there. All right, so this is now a much easier equation to work with. And so we distribute this 2 to both terms here. So we have 2 times x minus 4. And then over here, I don't need to distribute the 1, but I do need to distribute this negative sign to both terms. So this becomes minus x minus 3, and the right-hand side is 2. Now I simply combine like terms. 2x minus x is 1x. And then negative 4 minus 3 is negative 7. And that, of course, still equals 2. I add 7 to both sides, and I find that x equals 9. And 9 does not match either of my forbidden values, so I go ahead and box it in because that is my final answer. As a reminder, if this number did match either of these two values, then my answer would be does not exist. All right. So now let's look at what we have here. We've got 3 terms. I can see that x minus 1 times x plus 3 will be this term here, right? Because negative 1 times positive 3 is negative 3. Negative 1 plus 3 is positive 2. But I do have this additional x here and here. And so, actually, before I do anything, let's go ahead and note our forbidden values, which are 0, 1, and negative 3. And usually I like to write these in ascending order, so I probably should have written the negative 3 first, but it's really not wrong to write them this way. So my anal retentiveness is not allowing me to let that go, so I'm just going to rewrite it. There we go. That looks so much better. All right, so moving forward. Lowest common multiple is x times x minus 1 times x plus 3. And this can also be written as x times x squared plus 2x minus 3. So now we multiply the lowest common multiple by both sides of the equation. And for the left-hand side, I'm going to use this expression. For the right-hand side, I'm going to use this expression. And so we have here x times x minus 1 multiplied by x plus 3. And now we write the left-hand side of the expression. 1 over x times x minus 1 plus x times x plus 3 over 3. And this equals x times x squared plus 2x minus 3. And then we write the original right-hand side after this, which is 1 over x squared plus 2x minus 3. All right, so now we've got all the pieces in place. Now we do our work. Distribute this expression here to this term and this term. Note that on the first term, x times x minus 1 divided by itself is 1, leaving the x plus 3 and the 1. So we have the first term, x plus 3 times 1. Next guy, we have x times x plus 3, x times x plus 3. Right, this expression divided by itself is 1, leaving us with x minus 1 and the 3. Okay, moving on. X squared plus 2x minus 3 divided by itself as 1, leaving me with the x and the 1 here. And so this is simply just x on the right-hand side. And this went from a very complicated looking expression to a very simple expression to work with now. We just have to work it out. So we have x plus 3. Distribute this 3 here. So we've got 3x minus 3. And that all equals x. And so x plus 3x, that is 4x. And then 3 minus 3, well, of course, that is 0. Don't need to write plus 0, but I'm going to. And so we've got 4x plus 0 equals x. Subtract x from both sides, and we find that 3x equals 0. And so the solution is x equals 0. But wait just a minute. We already established up here, x cannot be 0. So even though we found that the solution is 0, that's not going to fly. Because, again, what is a solution? It's the value that makes the original statement true. So we have x equals 0, but x cannot equal 0. Therefore, no solution. And that is the final solution there. Okay. One more concept to look over, complex conjugates. We won't focus too hard on this, but it is something you want to be aware of. So we already have our conjugate pairs, a plus bi times a minus bi. So let's go ahead and work this through. So we're going to distribute that guy. So a times a minus bi plus bi times a minus bi. Distribute this a squared minus abi. Distribute this bi, so we've got abi again, and then over here, bi minus bi squared, so this would be minus bi squared. Right? We're just multiplying them together, but one of them is a negative, so we have a negative here. So notice those two are equal and opposite, so it's 0. And so what do I have left but a squared minus b squared times I squared. Now, what does I equal? It's the square root of -1. So this is, yeah, let's do it over here. I squared is simply -1 square rooted and then squared, or simply -1. So I squared equals -1. So let's come over here, replace that. A squared minus b squared times -1, which makes this a squared plus b squared. So if you have the sum of squares, then you can use the complex conjugate to break this apart. So we'll just do a quick example here. Let's say I've got x squared plus 4, and I want to break this into a pair of conjugates. Well, then this would become x plus 2y multiplied by x minus 2y versus x squared minus 4. And in that case, that would be x plus 2 times x minus 2. Okay. All right, one more quick one. If I have x squared plus 1, well, that's the same as x plus I times x minus I, right? Complex conjugates. And then versus x squared minus 1, well, that just becomes x plus 1 times x minus 1. Okay. And that is it for lesson 3.